ROS with Python. So that's why I use pip for installing this. But you can also use various. So if you want a C++ API for OpenVINO, you can use the yum installation steps for installing it. And also there are various kinds of steps. So 2024.1 is the newest version of OpenVINO, and it's much more optimized for running visual language models and large language model. So I'll definitely say to check it out. And yeah. So yeah, traditional object detection models versus vision language models. So traditional object detection models, I think almost everyone involved in robotics and computer vision has worked with. The most favored series is the YOLO series, YOLO V8, V9, and the recent one, YOLO V10 as well. So those are already available, right? But why do we need, again, vision language models? So vision language models, so traditional object detection models like YOLO models or like single shot detection. So these are very focused on a specific set of data set. So if you have trained your YOLO model on a specific data set, it will not be able to detect anything else other than that. So if you are, for example, I'm training my YOLO model on two things, cats and dogs. So if I provide an image, it will only be able to detect whether there is a cat or whether there is a dog. So it will not be able to detect other objects like humans, cars, bikes, anything else. But vision language models, so these are much more effective because they are based on the transformer architecture. So they will try to detect multiple classes. It's not, they are not confined to the fixed data set. For example, even if it's not trained on something like to detect cats and dogs, it will even try to detect that as well. And one more thing, vision language models, they take multimodal understanding. For example, for this workshop, I'll show you it will take vision input in the form of image, and it will take a language input. So language will be either it's a prompt or like it will have a question to ask from the image. And strengths. So strength, definitely YOLO models and the traditional object detection model, these are much more faster than the vision language models. They have speed, efficiency, and accuracy. But vision language models, since these are very new, like they have been much more used from last year, and from 2023 they have been mostly used. So they are still very new, so they are not much accurate if compared to traditional detection models, but they have a richer understanding of the problem or the problem's context which you are providing. And yeah, one more thing is you can do some language interaction with the model. For example, you can talk with it, so typing, or even you can provide some speech input to the model, and it will try to give you a specific output based on that. So that's the like downfall, which is like it is not much more doesn't have speed, it is not much efficient, vision language models, but they have rich understanding. And third one, which is the weakness. So traditional object detection models, so just like I said, they are having limited understanding. Like it will only depend on the data set they are trained on. So if you take a YOLO model, YOLO V8 model, I suppose, so it's trained on a COCO data set, right? So if you try to detect something which is not based on the COCO data set, it will not be able to detect it. It will because it doesn't even know what that particular thing is. So out of that COCO data set, it will not detect. But vision language model, since they are extensively trained, so they will be able to detect even if it's wrong, but it will try to detect something. Yeah, and vision language models, so those are very big models. So if you will try to run them, you will definitely need a GPU or a very powerful CPU. So they are very computationally expensive, and you will need some high-end models. So if you are having a weak CPU or an older GPU, so those not might be fast enough to generate an output using the vision language models. So the first demo, which I will show you, is the object detection and masking with GroundedSAM. So GroundedSAM stands for two things. So these are two different models. So grounding Dino and SAM. So grounding Dino is used for the object detection, and that particular detect object. So if you have an image, for example, okay, yeah. So here you have an image. You can see this image. I will be providing to the vision language model, and grounded SAM. I will run the model. So first it will run grounding Dino. So grounding Dino will try to detect the objects which have been provided to detect. So we will need to provide an input. For example, I need these four things to be detected in the particular image. So I am providing eyes, plate, hair, and spectacles. So grounding Dino. So grounding Dino will first take this input. It will try to detect these objects. See, it is trying to create it has created the bounding box for that particular prompts. For example, eyes. So eyes is the first one. So zero stands for eye. So zero, these eyes have bounding box. Second is plate. So this plate is having the number 2. That's why sorry, plate is having the number 1. So that's why these are also having bounding box. Then third one is hair. So this hair is also having a bounding box and with the bounding box number 2. And third one is spectacle. So only one person has spectacles. So this one has drawn the bounding box around the spectacles. Then once the detection is done, so it will do this run the second model, which is SAM. So SAM stands for segment anything model. So this is again a separate model. So segment anything model will segment that particular things in your image again based on the input. So SAM will again take this input and do the segmentation. So again, you can see it's running the segmentation. Hair is segmented, eyes are segmented, then plate is segmented as well, and then spectacles are also segmented. So grounded SAM is a combination of grounding Dino and SAM. So it will do both object detection as well as segmentation. So the user needs to provide an image. So one input image, and it will need to provide a text prompt. So based on a text prompt, it will do the object detection and segmentation. So there are various applications of grounded SAM. First one is autonomous vehicles, obviously. So if you are like having an autonomous vehicle and it is not trained extensively on all the things, so it will try to detect some objects. For example, it will try to detect the road. Hello. 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 Yeah. Do you have a question? Hello. Do you have a question? Okay. Yeah. I'll go for the questions at the end. So yeah. So applications of grounded SAM. These are like autonomous vehicles, inventory management, and robot grasping. So I'll go with the robot grasping one. So for grasping something with a robotic arm, you will need to detect the objects, right? So if suppose there is a table and it has various kinds of objects, so you will just provide the camera feed for the that table, which is containing multiple things. And for example, this is an image for the table which is having multiple things, and you will provide some input like grab the plate. So the robot arm will detect the object. So like it will detect the object, and it will output also give you, since you are having bounding box, so you will definitely be able to get the center point of the bounding box, right? The x and y coordinates. So once you get the x and y coordinates, you will be able to feed their coordinates to the robotic arm, and it will do the inverse kinematics for grasping that particular object, like the grasping the plate in that case. So yeah, grounded SAM comes into that. It will detect the object like plate. Once it detects the plate, it will give you the center point for that particular object, and then it will then go for grasping the clay. So yeah, let's go for the code demo. So yeah, this is the GitHub repository for this workshop. So I think this one was already shared with you all over email last week. So I hope everyone has followed all these steps. So these are going to take some time to install the Python dependencies, since these are quite big. So I'm not going to go through all the steps. These are quite pretty much like straightforward steps. You can just follow this and this will work out. And yeah, for adding the Python virtual environment package for like running your with ROS2 packages. So make sure to like replace this with your system name. For example, in my system name is Nilutpol. So make sure to replace this your username with your specific name in the system. And these are straightforward. Make sure to download the weights, and also so if you go to this Google Drive link, you'll find some models. So these models can be will be required for running the inference. So first we will run the okay. Let's skip this, since this will actually take up some RAM, so it might hang up my system. So let's keep this demo for the end. Let's go with the second one, the visual question answering. So yeah, the second demo which I prepared is the visual question answering using Blip. So Blip is a language, again, vision language model. So it is pre-trained for like taking inputs from the user, and it will do multiple things. It's not just for detection or that. For example, here are some examples of using Blip. So you can do object recognition. So if you just give it a question like what is shown in the picture, so you'll provide an image, and what is shown in the picture like this, and it will detect whether it's it's a human, it's an animal, it's a bird, or anything. So object recognition can be done, and again object detection. So object detection can be done. For example, you have a dog in an image, so it will detect is there any object in the image. So if there is any object, so you're not asking any question like this part. So if there is any object in the image, it will specifically give you that, yeah, there is an object in the image and it's a dog. Again, for example, scene recognition. For example, you are providing an image which is showing whether it's raining or not. So you just ask it, is it rainy? And it will specifically give you the answer like, yeah, this is the image is shown as raining. You can also do object counting. So for this demo, I will be showing you how to do object counting. So you have an image, there are multiple players. So you will just ask the image how many players are there, and it will give you an output. So, and multiple things. Again, you can also go for activity recognition. It will give you the activity of that particular person in the image, and also it will give you like some captioning. Let's go. Yeah, for this demo, I'll be showing you this. See, I'm providing this image, so you can correctly see there are 3 boxes in the image. So I'm just asking the question, how many boxes are in the image, right? And it will give me the answer 3. Again, in this image, like people are in the restaurant, they are having food. So I asked it, how many plates are in the image? Like you can correctly see there are 4 plates, and it also gave me the answer 4. So let's go to the demo for this second one. Yeah, so I'll start by this one, the steps. I'll make sure my Python path is correctly there. I'm inside my workspace. So again, you can follow these steps. You have your workspace, ROS2 workspace, then src folder, which contains this particular repo. Then make sure you have already downloaded the weights. And again, so, yeah, so this is my repo. Sorry, src folder. This is my repo, ROS2 VLM, and ROS2 VLM again. Yeah, these are the two codes. So this is the code for the first one, GroundedSAM, and this is the code for the second one, the Blip visual question and answering. And inside these modules, so the Google Drive link. So the zip file which is inside this Google Drive, you will need to place this inside this OpenVINO IRS folder. So there are 10 model files. So this model will already this OpenVINO IRS will be already be there, and make sure you put this correctly. Second, checkpoints. So again, this will be downloaded by this script. So if this download weights.py script runs correctly, these 3 folder will be created correctly. So no need to worry about that. Just run this Python 3 download weights.py, and this will be correctly downloaded. But just you need to make sure this OpenVINO IRS contains this model files from the Google Drive link. So let's, the first one is Blip Visual Q&A. So I'll just give a brief overview of the code. So yeah, as you can see, I'm using OpenVINO module for running inference, and there are some parameters like device. So just like I say, if you want to run your OpenVINO models inference, you can run it on a Intel CPU, you can run it on an ARM CPU, Intel GPU, Intel FPGA, or even the newer Intel NPU, the neural processing unit. So just make sure you provide this. So I'm by default, I provided the GPU 0.0. So yeah, let's check how I can know if I have the correct Intel OpenVINO supported hardware. So I'll just run Python 3. Yeah, import OpenVINO SOV. Okay, yeah. See, you can see I am having the CPU and the GPU. So I am having both of this, the Intel CPU on my system, and also I have a integrated graphics card. So it's showing me the GPU. So also I have the NVIDIA GPU, but NVIDIA GPU doesn't support OpenVINO toolkit, so it's not showing this here. So it will only show you the supported system which can run OpenVINO toolkit. So yeah, let's go here again. So again, declare parameter. So the first parameter is device. So device will be again the device for running inference. Second will be a question. So you are providing an image here. So, and what question do you want to ask? So by default, it's showing us what is in the image. So you can also specify your own image question in the command line. And third one is the image path. So you'll definitely need to provide an image for asking any question to the model. So yeah, so these are the model files, the XML files. So vision model, text encoder, and the text decoder with past. So I'll explain how this vision and encoder decoder works, but let's go through the demo ones. And here it's creating the object for the Blip VQA class, and then it's running the inference. So once it runs the inference, it will just give you the generated answer. Like what's in the image, it will give you an answer. Again, inference time, like how much time did it take for running inference on that particular device. So yeah, let's run. Okay. Yeah. So I'll add the Python part again. Yeah, so home and then username should be the username of your system. So mine is Nilutpol. I'll just update it here. Yeah, it's correctly showing. And also I can check it using echo dollar, then Python path. So yeah, it's showing correctly. This one is the correct. So now actually it will be able to access all the modules like OpenVINO and everything. Okay, yeah, and also I'll need to so yeah, I also need to activate my virtual machine. Sorry, virtual environment for Python. Yeah, virtual environment is active. And now just build. So I'm building the workspace. Yeah, it's finished. And source it. So this is the first node, the blip visual Q&A. So let's run it. ROS2 run. ROS2 VLM, and then this one, blip visual Q&A. So for running this visual question answering node, you will need to provide a few things as ROS arguments. So here you can provide ROS arguments. So first is device name. So by default, it's again taking the GPU. Second one is your question. So again, default question is what is in the image here, you can see. And third one is the image path. So you need to provide a specific image for running your inference. So let's provide this. So yeah, first I will provide a device. So yeah, let's run in our CPU first. CPU, just provide CPU. Okay, inside quotes. Second, you need to provide again dash p. You need to provide a question. Like let's see the image once. Okay, let's try to see this image. Let's ask how many dogs are in the image. Okay, yeah, how many dogs are in the image. Okay, and next, third is your image path. So image path, let's copy this. Yeah, dog.jpg. So it's provided. That's now. So I provided three arguments. First is the device. So I'm giving CPU here. Second is the question. So you need to ask a question based on the image. So I'm asking how many dogs are in the image, and third is the path to the image. So let's just run it. Okay, okay. Yeah, I did a mistake. This one should be. Yeah, this one should be image path. I give as device image path. Yeah. So yeah, it's showing the output as the inference device as CPU, which is provided, and question. Yeah, it has already generated the answer. Like generated answer as 1, and inference time it took is just 1.43 seconds. So this time was taken 1.43 seconds for running inference on your CPU. So based on my CPU, this was the time taken. So let's run it again on a different image. Or else, yeah, let's change the question. How many human are in the image? Yeah, same image, just a different question. Again, yeah, you can see there is one image, sorry, one human, and it's providing me the inference time. So let's change the image this time. Yeah, this box. So the example which I've already shown, box 3, let's run it. How many boxes are in the image, and the image path is correctly given. So yeah, you can clearly see there are 3 boxes in the image, and it's also showing me the answer as generated answer is 3. So let's run again, but change the device this time. So I was currently running on CPU. Let's run it on GPU as well. So I'm providing this exact name which was provided here. So you remember the available devices were CPU and GPU. So you need to provide exactly this GPU, the same input. So that's why I'm providing GPU here. And let's run. Yeah, again, I got the same answer, but since it's an integrated GPU, so not that powerful. So it took a longer time than the CPU. But yeah, it's working correctly. So this time this inference was done on the GPU instead of the CPU. And yeah, let's again try for another image. Okay, yeah, let's try for these bottles and see how many bottles are there. And let's change back to CPU. So yeah, device is CPU. Question is how many bottles are in the image, and the image path is this bottles.jpg. So yeah, it's showing me the answer is 4. So it's not correct. Clearly there are 5 bottles in the image, because sometimes yeah, like just like I said in the PPT. Yeah, just like I said, vision language models are quite new, so those are not quite accurate. Sometimes they can have faults. So here you can clearly see there is a fault, like there are 5 bottles, but it's showing me 4. So these are constantly being improved, and so that's why it gave me a wrong answer. So one way to improve this is to do fine tuning. So I'll explain this again in the end. So this was the demo for this blip, the visual question answering. So yeah, my demo only showed like it was detecting like not detecting, it was object counting, but you can also try out various other things like which is not like right now not available in my code. So you can also do object detection. You can ask him like what is shown in the image, what kind of objects are there, and object counting is already what I've shown. You can also use it for scene recognition, spatial relations, and among objects. So I'll say you can explore the notebook here. So yeah, you can check out first this OpenVINO notebooks. So if you're having an Intel supported CPU, GPU, or an ARM CPU, you can definitely go. So MacBooks are based on ARM CPU. So you can definitely, if you have a MacBook, you can also use OpenVINO, or if you have Intel supported CPU, GPU, check out this OpenVINO notebook. So if you go to this OpenVINO toolkit, OpenVINO notebooks, just go here and this one, click on this link, notebooks at GitHub pages. So there are tons of examples, like you can see text to video retrieval, animating open domain images with dynamic creator, or see you can also create in your own LLM agent using OpenVINO. This one is a Lava next. So Lava, it's a quite popular vision language model. It's a both very powerful model. So it will also take both uh, visual input and also textual input. So yeah. So yeah, this one is a visual language assistant with Lava. So since it's a visual language assistant, it will take inputs, visual inputs, and also it will take questions. So, example, yeah, this one. So it's taking an input image. It's taking an input prompt. What is unusual on this image? See, it's taking. Then it will give you an output like detailed answer, like the cat is lying on its back inside a cardboard box. So this is quite unusual for the image. So it will give you all the details based on your like inputs. So there are multiple examples. You can also use image to video synthesis. So in this example, you are just providing an image and it will generate a video based on that. You can also have multiple examples of stable diffusion for generating images based on just user prompt. So users provide text. So text to image, just provide text and it will generate an image using stable diffusion. So this one is a stable diffusion example. And there are other stable diffusion examples as well. Uh, yeah, you can also check out this, like you can line level detection, or you can also do your voice cloning just running on your Intel CPU, GPU, or ARM CPU. You can do your voice cloning as well. So there are various examples. These are quite impressive. So check this out. And so the second, the visual Q&A using Blip. So this was based on this notebook, visual question answering and image captioning using Blip. So my example was only for visual question answering, but you can also do like image captioning as well. So here, let's see an example. See, you are providing an image and it will immediately do the captioning. So like, see, you can see, if you see the image, you can clearly say that there is a cat sitting on the road. So that's what even the model gave us, like cat sitting on the road. Or so this one was for captioning, image captioning, and this one is for visual question answering. Like give the image, ask a question, and you get answer. Like who sits on the road? Cat. So another example will be this. See, this is a much more impressive example. So you're providing this. So this is a river. It's having multiple bridges. So it's asking like how many like bridges are there in numbers. So you'll give the user prompt as a query, take the input and it will provide the answer. Yeah, so how many bridges are there? It will give you an answer like there are 7 bridges in the example. So it not might be always be correct, but you can fine tune it using your own data set. So yeah, like this code, the Blip Visual Q&A. So it uses this Blip Visual module. So if you go to this modules, check out this Blip Visual. So these are all the functions. Again, these functions are exactly based on this this OpenVINO notebook for visual question answering using Blip. So if you check out this, you will definitely get this. Like you can follow the step-by-steps for running on your own system, and also run this ROS-based code as well. So it just if I go to the ROS2 code, you'll see it's just creating the object by providing the image path. So, yeah, here it's creating the object, and then it's running the Blip inference function. So Blip inference function will generate an answer. So it takes the image path, question, and the maximum token length, and then gives the output. So it's quite straightforward. So then the second example will be, so yeah, this one was the visual Q&A using Blip demo. Let's go for this GroundedSAM. So yeah, as I already said, GroundedSAM is used for object detection and masking, and it has I've already explained the robot grasping example. You will get a output similar to this. You will get this bounding boxes. Then also you will get segmentation along with the bounding boxes. So, and yeah, you might already know if you have bounding box, you need the X and Y coordinates, right, for generating the bounding box. So using that information, you can exactly get the center point of the code, the bounding box, so that you can like either do some give it to a robot arm for grasping, or you can also do some other stuff like creating point clouds. So various examples, like various applications can be created based on this. So I'll run my ROS2 code. Yeah, again, this GroundedSAM example is again based on this one, this notebook, object detection and masking from prompts with GroundedSAM. So if I go to my GroundedSAM code, so again, it takes 4 arguments as command line arguments. First is the video source. So video source can be either a video file, MP4 video file, or any kind of video file, or it can also be your webcam input. For example, in Linux, you have, wait, I'll show you. Again, second one is the device. So device is again the device for running inference. So it should be an Intel supported device for running OpenVINO. So by default, it's CPU. So you can provide your GPU as well. Then each segment. So by default, it's false. So if it's false, then there will be no segmentation. There will be only, so there will only be detection. So it will just do bounding boxes for the objects provided. There will be no segmentation like this. So by default, it's false. But if you provide true, then it will also do object detection by bounding box, and also it will do the segmentation as well. And this is the detection list. So detection list is the list of objects which needs to be like detected in the image. So this needs to be provided as a prompt by the user, but by default, it's getting only %. So let's run it. It's creating a video captures object. It's taking the video source, and it's taking the first image of the video, just the first image. So not running a loop, because it's quite a big model and it will like use much of my CPU. So there will be no real-time processing. So I'm just taking the first image. So if you want to run it on a video, so you can just use a while loop here, and it will keep on running on a video loop. but right now I'm not taking it. So it will just capture the first image of the frame. So it will convert it first, convert into a PIL image format. So this image is this one. What is it? Yeah, you need to import the image function from the PIL module. You import the module and then convert it into the appropriate format like BGR to RGB, and then you use it for processing. So this is the main function, process the image. You need to provide like the image source, then the detection list, and the each segment. So this each segment is, if it's false, then there will be no segmentation. If it's true, there will be some segmentation. And then just it will show the image and also write the image into your system. So let's try to run it. So check this OpenVINO notebooks. You'll find it much more easier. Like also check out all the examples which I've already shown you. Like you can have stable diffusion, you can have voice cloning, you can have zero shot, identity preserving examples. For example, yeah, text to image. Again, yeah, depth estimation. All these are using OpenVINO and it's easy to run. Straightforward Jupyter notebooks. So you don't need to change anything. Just run the cells and you will get the output. See, there are already 3 to 4 examples of stable diffusion. So definitely check this out. And so let's run it again. So yeah, so I've also explained all the CLI arguments. You can go through it in the repo for both the examples. So this is for the blip visual Q&A. This is for the grounded SAM. So let's run it. ROS to run. ROS to run VLM and grounded SAM. So yeah, let's provide the arguments. ROS args p. Yeah, first I'll provide device. So let's provide CPU. Okay, next one is segment. So let's skip it false now. We don't want any segmentation for now. Third one is your video source path. Okay, yeah, video source. So I will be using my webcam, USB webcam. So if you want to check out your video sources, just go to a terminal and type ls space /deb, then video, then just star, and you will see all the available sources. So this video 0 is my built-in webcam, and video 2 this one is my USB webcam. So what it will do is it will open my webcam. It will take the first image frame, capture the first image, and then run the groundedSAM module on it. So okay, yeah, I'm giving the video 2 as the video source. Each segment is false, device is CPU, and I need to provide the detection list. So yeah, let's provide this. I'm providing the detection list as I want to detect eyes, person, and hair. Okay, let's just enter. Yeah, it has taken all the inputs. Video source, CPU is inference device, segmentation is false for now, and the detection list. So yeah, it's taking some time. As I've already mentioned, these vision language models are very computationally expensive. You need a high-end CPU or GPU for running those. So like my system is not that powerful, so that's why it's taking some time. Yeah, this frame is, I guess, open. Okay, I guess it was not clearly done. Let's take a video source, right? So yeah, I have this test video. So yeah, this is a video of horses. So let's try to detect the horses. Let's give the path. Yeah, so in video source, change the path. So I was giving my webcam path, but let's just change it. Code. Uh, so yeah, inside codes, the path. Test video. Again, close the quotes. And then change the detection list. So I'm not going to detect any person in the video. So let's keep it just horse. And here's not there. Let's try to detect the sky. Yeah, let's run it. So yeah, its segment is false, video source is given, and the detection list is just horse and sky. Okay. Let's just take horse and sky. So you can already see it's taking video source path. This inference device is CPU, segmentation is false, and it will try to detect these two things, horse and sky. CPU is already being used almost. And it's input size. So see that it has correctly read the video and taken the first frame because it's giving me the input size for the first frame. So it's 12 pixels. Okay, yeah, took quite some time, but here's the output. So you can see it's detecting the horses, drawing the boxes. So zero means the first object, which is horses. And you can also see this blue line, so blue blocks. So it's actually detecting the sky as well. So yeah, it is detecting almost all the horses inside the in the back as well. So yeah, and again, if I run, okay, yeah, it's closed. So again, if I run this each segment as true, let's try this. So yeah, segmentation is true this time. So let's wait for the results. So it's taking some time because my CPU, like my CPU and GPU both are quite old. But yeah, here is the result. So here you can see right now it's detecting the object, drawing a bounding box, and also doing the segmentation here. So even the sky is segmented with blue and the horses are segmented with pink. So this is the result. Let's close this. Okay, so this was a demo for both. Let's run another demo for the second one, the blip one last time. So let's take this image. Okay, yeah, let's take this image. Okay, so let's take this image and try to count the number of people in this demo 3. Yeah. Yeah, blip visual Q&A. So I already have the device's CPU question. I'll try to ask the number person, and the image partner is demo 3. How many humans are in the image? Okay, yeah, let's run. And so yeah, the device CPU question is how many humans are in the image and image path. Okay, here's the answer. It took quite some time, 16 seconds, but yeah, it gave me the answer is 8. So I can clearly see there are 9 people, but maybe it missed out on the people on the back, someone. But yeah, it's almost closer to the answer, which is 9, but it's giving me the answer is 8. So yeah, so if you want to improve the accuracy of the model, for example, the blip model, so this blip visual Q&A model, you can go to its okay, yeah, go to the blip official repo. So this is the blip official repo, and blip stands for bootstrapping language image pre-training. So if you go here, you'll see some examples for fine tuning. So fine tuning is like training your model. Like you have a large model, like a large language model or a large visual model. So you can do the training on based on your data set. So that's called fine tuning. So yeah, there are various ways for fine tuning. Fine tuning with VITL. Then again, you have thing. Yeah, you also have the data sets. So you can modify the data sets, look into the data sets. But yeah, the problem is like for fine tuning these vision language models, you need a very high end GPU. Even your Google Colab Pro, which is easily accessible, it will not be efficient enough. But some newer models, like for example, there is a newer model by uh, Google, which is called Polygamma. So this Polygamma model is it's a very powerful model. So if I go here, so this one, this Polygamma. So this Polygamma model can be fine-tuned very easily on even on Google Colab. So you need to create your own data set. So I'll show you that fine tuning. Let's go. Yeah, this is RoboFlow. So they very good tutorial on fine tuning a Polygamma model. So again, Polygamma is also a visual language model. So it's a large multi-model model, but it takes both visual as image input and text input as in the as prompt. So that's why it's also a visual language model. So here you can see. So they are already providing a data set. So that data set is this X-ray data set. So they have this cracks and they have already like annotated the data set. So you can follow all these steps and you can easily do the fine tuning on a Google Colab notebook. So just do fine tuning, and here you can see they are testing by running the inference on the train model. It's quite giving us pretty good accuracy. Like it's correctly detecting as you'll see, it's correctly detecting all this as fractured. So I'll ask like definitely go to this OpenVINO, check out all the examples. Let me know if you face any problems. I can help you out definitely. And yeah, that's all from me. Thank you. So yeah, any questions? Any questions? Hello, am I audible? Hello, can someone confirm, please? Hello? 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 So, hello? Yeah. Yeah, do you have any questions?
Fine.
Yeah, please go. You can ask the question.
Will that work now? I have to change it to monitor. Yes, okay. So can you hear me?
Yeah, I can hear you.
You can test mic. Hello?
Yeah, I can hear you. Please go on.
Sorry, let me. You know what? Hello? Yes, working. Yeah, but is it taking it here? Hello?
Yeah, I can hear you. Please go on.
Check the options first. That's the correct one.
Hello, you can ask the question.
Hello? It's meant to.
Let's confirm.
Yes, you can ask the question.
Somebody hear me from the conference. Okay, it's working. All right. Okay.
Okay. So here's my question on the repo. I saw the Nilutpol always supports CPU, GPU, and NPU. So are there any specific
Yes.
reasons for not supporting CPUs?
So like just like I said, I'm using the OpenVINO toolkit from Intel. So like they are supporting their range of products. Like they Intel OpenVINO supports. Hello, I'm audible. Hello, am I audible? Hello, can you confirm if I'm audible?
What was wrong with you guys? Okay, this one. I'll tell you. Yeah, you know what? All right.
Okay. Okay. So yeah, on the repo. Okay. On the repo, I
Yes.
noticed the supported processing units are CPU, GPU, and NPU. Are there any specific reasons for TPUs not being supported?
Okay, it's specifically supporting Intel-based CPU, GPU, and NPU, but it also supports ARM-based CPU as well. So if you are having this ARM-based CPU, like a Raspberry Pi or a MacBook, so MacBooks are their CPUs are based on ARM-based system, right? So you can also run in this on MacBook. You can run on a NVIDIA Jetson system. You can run on Raspberry Pi, and also you can run on your that any kind of Intel products. So they are rapidly expanding right now. So right now they are only supporting this range of products like Intel-based products and ARM-based products, but they are also expanding it to other systems as well. So is this clear?
All right. All right. Hello. Good afternoon.
Yeah. Hi.
Yes. So I saw in your your video when you were doing your testing, you were monitoring your CPU and other parameters on your system. So what are the hardware requirements to run this OS? So what like hardware, what computers are you looking at?
For running this code, right? For running this like visual language models.
Yes, for running the software, so to carry out this activity you're doing. So what's like
Okay.
what would you recommend as
Okay.
specifications for hardware for your computer?
Okay, sure. So this vision language models or even like LLM models like chat GPT or anything, so these require very high-end GPUs and CPUs. So that's why I was actually monitoring my CPU, because my CPU is not that new. It's quite old, like 4 or 5 years back old. So that's why it's not that powerful. So I was making sure it's not taking too much CPU to like crash my system. So for if you want to run this correctly, like in a very efficient manner, I would definitely say like go for a very powerful GPU, or even go for a powerful CPU as well. Like I would say Intel-based CPUs are quite powerful, so go for them. And also, if you are not using this OpenVINO toolkit, like you can also use the NVIDIA CUDA for running as well. So you can go for NVIDIA-based GPU. So those are the newer ones are very powerful, and those are quite efficient.
Okay. So I see. So you use the OpenVIRA as like an extra, like a cloud-based system.
No, it's not a cloud based. It's everything is running on my laptop locally. It's not running on any cloud.
How does
So I would say
OpenVIRA work exactly?
so OpenVINO is like it's a tool. So I have my vision language model, and there on the other end I have like that's me. So if I want to run my model, so what it will do is uh, OpenVINO will convert that particular model into a specific format, and that new model format can be run on any range of products like Intel CPU, GPU, or ARM CPU, anything.
Oh, okay, I see that. So my
Yeah.
second question is this. So this large language models you are working with. So I guess most of them are, pre-built and they are out made out like they are custom like out of the box, type products. So if you were to build something of, to do a task of this capacity, what would you just the how would you go about that, or just any insights you have on that would be nice.
So you want to create your own like vision language model from scratch.
Yeah, I was just saying, yeah, exactly. So if we're going to build something like that for the purpose of this tax we're doing, how do you like? So what like what need to do that? Like so let's say knowledge wise, requirement wise, all of that.
So okay, so for creating your own system, such system from scratch, it will take much more effort. Like you need to have a huge data set. Even I think if you have worked on computer vision models like YOLO, you might would have come through the process of collecting data set, then annotating. So even that much data set is not enough. It will require huge data set, and again for training, it will require very powerful GPUs, not just single GPU, multiple GPUs. So it's not like very user friendly for a people like us to do it. Like it will require a big organization to do it. But you can what you can do is you can fine tune. So at the
Okay,
end, I
so I
explain
see.
about fine.
So basically, the last question will be about. So there was a time when. So how would you? So like just reward application of what we just saw here, because I could think of a couple of them. Like so, say for example, if like so, say for like a military application would be, I can try run this on a drone, or maybe I don't know, I can have it like running on the drone, and then the drone kind of mirrors the software remotely or something. So how would you so in the like so as of today, like what we have now, how efficient are they at like visual tasks, as like so like modern day application or real time application, or any scenarios or any examples you could give us on these things?
Okay, so these visual language models are like for if you want to do some serious task, like for example, rescue operation. So I would not say go for this visual based models right now, because this model just started coming from last year, like 2023. So they are still very new. So people are constantly improving them. You can efficiently use fine tuning to improve the accuracy, but you cannot be very much efficient. Like it's going to be that much accurate. So if you are trying to run on a drone, you'll for running on a drone, I would say go for like a NVIDIA GPU based like a Jetson platform. So those are quite optimized NVIDIA platform. So check out the Lava model on running on a NVIDIA Jetson. So check that out example, and if you have a Jetson system, then you can definitely run it. And yeah, like that's what I said. Like it's quite new, so you cannot be sure like it's going to be that much accurate.
Are there any older models? Are there any modern
Yes.
models that are that can do such tasks as of today?
There is the paid model of ChatGPT, which can take image input and detect some things. So you can try it out as an API, because see that model will be quite fast because it's running on the cloud. So it's definitely going to be fast.
Oh, okay. Okay, I see. So the last thing is thank you very much for your time, and this was very insightful.
Thank you. Thank you very much. Thank you for attending, everyone.
Does anyone have any
Uh,
questions?
yeah. Any more questions?
So I guess that will be all from our side.
Okay. Thank you.
Okay, hello, can you hear me?
Yeah, I can hear you.
Okay, I want to know if you can run it on a Google Colab.
Okay.
I say, can you run the model on a Google Colab?
Yeah, you can definitely run on a Google Colab, and Google Colab has a powerful GPU, so you can definitely run it much more efficiently.
Okay.
Yeah.
Okay, thank you very much. This will be all for now. Or do you have any other thing you want to say to us?
No, I like explain everything. So I would say I've already shown you the OpenVINO notebooks, right? So I have also included the link in the repo which was shared with you all. So you can go through it. Like I would say, try to run the examples like stable diffusion, voice cloning, image generation, and like anything like detection, question answering. So there are hundreds of examples. Go through them, try to run them, and you can definitely come up with some good applications based on that.
Yeah, yeah. So real quick, I just thought of something.
Yes.
So I thought of so this the application of this our image model for like text documents.
Yes.
Just can you give it speak to like the accuracy of this for like images, or like, so when I say image I mean text document images or any of PDFs or any of those things, like how useful is it for such applications? Thank you. Or like say you forms, hand fill forms, like say people filling forms. So take for example, you have like say people going to the bank writing checks. Can you use like some kind of some kind of scanner to like pick out the text from what people have written using these language models?
So yeah, I'll share my screen once.
Sorry, we can't hear from our side.
Yeah, I'm just sharing my screen. So, can you see my screen?
Yeah, we can.
Yeah, so in this OpenVINO notebooks example, you can see there is a line level text detection. So if I go open this, and another should be text one.
That'd be mad, I swear. If you could use it to, like, say, pick out text from stuff people do. It'd be a very useful application for it. No, no, it's stress.
Hello. So it's taking some time to load, but this line level text detection, what it does is it detects the line of the text, and then it will detect the text what's written in it. So based on your application, just like you said, detecting some text. So like you can definitely make up something. So if you're having the idea, check this notebook and maybe come up with this an application.
Oh, okay. Most definitely, we'll check it out.
Yeah. So if you go to my repo, the repo we just shared, just go down and you will see this OpenVINO notebooks. Just open this OpenVINO notebooks and you will have this
Oh, thank you
GitHub
very
repo
much.
again. Yeah, and then go to this one, this OpenVINO notebooks at GitHub pages, and you will get this whole page. All the examples are there.
All right. Thank you.
Okay, thank you.
Yeah, all right. Thank you, Nilutpol. So that will be everything for today. Thank you so much for showing up on our meetup, and
Thank
we'll
you.
likely get
Thank
back
you.
to you for some of the details on the repo. Yeah, thank you,
Okay,
and
okay,
see you later.
sure. Okay, thank you, and all the best to everyone from the ROS Nigeria community. Okay, thank you. Bye.
Okay, thank you. Same to you.
Okay,
Bye.
thank you. Bye. Bye.
Yeah, all right. So you can. That's funny. So I know this didn't really go well the way we planned it. Yeah. So first of all, I will apologize for our first speaker that was not here. He's actually sick. He's not feeling fine, so he couldn't come, and it was like serious, so he couldn't come. Yeah, so that's for our first speaker. So on the other hand, we have some. We always have. This is our second meetup, and it's like we are usually having some technical issues. So we're even thinking maybe our next meetup might be virtual, because if it is virtual, we won't have audio problem. We're always having audio and video problem. Yeah, but if it is virtual, there won't be such kind of problem. No audio problem or video problem, because everybody is just like, you share your screen, you see it from your side, so there won't be that problem. Yeah, that's the other side. You have to.
Yeah, if I may
It's
add,
always a
maybe you can
trade-off.
also organize.